in this question here, we are being told that calculate the observed fringe width of a Young's double slit. Experiment using a light of a wavelength 600 nanometers and a slit 0.5 millimeter apart. The distance from the slit to the screen is 0.8 meters. Now, at this question here, what you need to know when you need to calculate the observed fringe width is we say x is the observed fringe width equals to lambda times d over a. Now, at this question here, you need to know that this x is the observed fringe width. That's either within the trough and trough or crest and crest. This one here is the lambda. Lambda, it is now the wavelength of the light. Then d is the distance from the slit to the screen. Then a here is the distance between slits. Distance between slits. Okay, so when we have the distance between slits here and we have this point here, then there is something I need to show you here on how to know which one is the observed fringe, which one is the wavelength, and which one is the distance from the slit to the screen and the distance between the slits. Here at A, when you see this image at A, it means the distance between the slits. That's at A. Then at D, this is the distance between the slit and the screen. So let us now continue. That's x observed fringe is equals to this one. Now for us to find observed fringe, x is equal to the lambda we are given, that is 600 nanometers, but we need to change it into meters. We multiply by 10 raised to power negative 9 times the distance we are given between that one, the distance of the double slits, between the two slits, it is going to be slits here, that is 0.8 over, then the next one, because now we need to divide by the distance between the slits. The distance between two slits, that is 0.5, but we change it into meters because that's our unit of distance is meters. Now we multiply there by 10 raised to power negative 3. So at this point here, it is going to be 600 times that one. We are going to get what? 600 times this one times 10 raised to power negative 9 times 10 times 0.600 times 10 negative 9 times 0.08, it is going to be 4.8 times 10 raised to power negative 7 over 0.5 times 10 power negative 3. So you can look here, take 4.8 divided by 0.5, we get that is 9.6 times. Because this division here, I need to show you on how to simplify this one. That is 10 power negative 7 divided by 10 power negative 3. This is now the same as 10 power negative 7, because of the indices. When we have division, we subtract, which is going to be 10 power negative 7 plus 3, which is going to be 10 negative 7 plus 3, we get it is negative 4. So here we multiply by 10 power negative 4. So the answer it will be 9.6 times 10 raised to the power negative 4 meters. Or you can say it is 0.96 millimeters. That's now the distance of the observed fringe width. Now at this point here, this one, it is on how we can solve the powers when we are given the indices.